Good day to one and all. What is now proved was once only imagined. This is the core aspect that we as a team believe in. On that note, allow me to present my team, HAL-2020, delegates of 11B. Our team leader, Cherian John, along with myself, Edwin Shibu, and Abel Abraham Saji, are aspiring to carve a niche for ourselves in the tech-savvy world. Now, let's move on to our concern. It's time to tackle the challenge of e-waste. The world produces 50 million tons of e-waste a year, and only 20% of this is formally recycled. UN agencies has come forward with World Economic Forum, the Global Environment Facility, to call for an overhaul of the current electronic system.
On to how 3D and 2D printing will be useful for the future. Today itself, 3D printing has started playing a crucial role in almost all sectors of the economy. It has become an integral part of industries such as medicine, fashion, construction, etc. Here in Dubai, entire buildings were made using 3D printers. With the growing importance of 3D printing, we should work towards making it more economical and profitable. Our project is a mini CNC 2D printer. It can be used to make simple drawings and photos. It is completely homemade and handmade from scratch. Now, Abel will explain the steps of production that were involved in making this printer.
Hi, this is myself, Abel Abraham Saji, and I'll be taking you through the procedure in making our project, the HAL-2020. The first step are the components required for making this project. Two used external DVD writers bought from a local hardware store, one Arduino kit, 2 into L293D motors, 10 nuts and bolts. These components can be bought online through Amazon or eBay. The rest of the components are one metal piece or slab, soldering wire, wax and a solder, one aluminum piece. These components can be required from a local hardware store. Step 2. Preparing the translation system. Dismantle the old DVD players to get the translation system with the stepper motors. These translation systems are essential for the functioning of the CNC. We require two of these systems for the y-axis and the x-axis. Step 3. Preparing the stepper motors for the x-axis and the y-axis. It's better to solder the wires on the flexible connector, but it's not an easy task as you require to split the 4 wires using a cutter. The first wire corresponds to the first output of the L293D and so on. The wires help in connecting the motor on the translation system to the breadboard. Step 4. Printing 3D parts. For this step, we will use recycled material for the printing of the parts. The parts are as follows: 4 mounting brackets, 8 spacers, 4 breadboard holders, a Z-axis base, a pencil case, and a pencil anti-tilt ring. Step 5. Preparing the circuit. The circuit is really easy as you can see below. One L293D for each axis and a servo motor for the Z-axis. Step 6. Pen/pencil case. The diagram shows the pen case made using Fusion 360. The pencil is held by the pencil holder on the Z-axis base. The servo motor present in this figure helps the pen/pencil move up or down as it is not required to be in contact with the surface at all times. The yellow object present at the back of the holder is called an anti-tilt ring. This prevents the pen/pencil from tilting left or right when it moves. The diagram shows the components from the circuit of the project. The two stepper motors are connected by 4 wires to the Arduino and the L293D motors, which help in controlling and limiting the servo motor's movement up and down using a clockwise or an anti-clockwise movement.
We take this moment to express our gratitude to our mentors, Miss Masha, Miss Sumi, and NMS throughout HAL 2020. It was a great learning experience, fresh hand for our team. Signing off, HAL 2020.